y'all, and welcome to the most electrifying podcast on social media. I'm your host, Willie Snyder from NEC Code, coming to you live from the Mile High City in Denver, Colorado. I'm joined by my awesome co-host, Mr. King James Stallcup, over there at Stallcup Electrical Education, over there in Big Sky Country, Texas, Longhorn Country. And we're going to be bringing you some more Journeyman/Master exam prep tonight. And James has a really good course put together. We just ask that you guys subscribe to the channel. Tell your grandma, your aunt, your uncle, everybody in your family to subscribe to the channel. And we got some awesome material for you to study for your upcoming exam. And I really want to thank everyone. Big shout out to everyone. NEC Code had a really good post this week. We had a lot of participation. I hit 80,000. And it's just really awesome to be doing this every week. I have a lot of fun putting this together. We're coming to you a day early because I have a meeting tomorrow that I have to do. So I appreciate you, James, for putting together short notice. And I think we got it together. I had to put together a really super easy quiz this time. So I know you're really gonna slam dunk these. I know you know a lot about batteries and stuff. So this week it's going to be on lithium-ion batteries, and so I know James is going to get a lot of these off the top of his head. So I gotta really dig deep to try to find ones that he's gonna guess good at. So it's a lot of fun doing these. So
they're not going to be easy. Sir. I can already tell it's going to be guessing again. Shit, give me that.
Well, I work hard to try to put them together and get something decent, to where, we have a lot of fun doing it. And like I say, like the meme this week, I just kind of came across it and it was pretty funny. So I guess we roll the meme real quick.
All right, let's see what you got this week.
What really cracked me up was that butt splicing.
State of the art, baby.
Yeah, I don't know who's putting 22 longs in fuse holders, but that was pretty funny.
It just goes to show you never know what you're gonna see.
Yeah, yeah. That's actually kind of an old picture. It's kind of been floating around a little, but I ran across it and I just thought, you know what, I'll run this for the meme this week, and it's pretty fun to make them and just mess around doing these every week. I just really enjoy it.
It's all about. Just have fun doing all this stuff. I mean, that's what it's all about. I was gonna say, I was checking before I come on. I went over to the YouTube site. We've got 230 subscribes on there already.
Nice.
I was shocked. I was like, wow, man, people are really come on. But the thing that amazed me is how many viewing hours are on there. Apparently, there's, I think they're coming in and doing the German, but they're seeing all this other stuff that's on there. And we're getting views on all kinds of stuff over there. So kudos, everybody. Appreciate it.
Yeah, the last time we did a Wednesday, we didn't get nobody because it was such short notice. So we tried to get the word out this time. But it's always a lot of fun doing this, and the myth of the week kind of just came up. Dude, it's so crazy. I get so many myths. Like, everyone is like bombing me with myths. Like, oh, you should do this, you should do that. But this one, you were kind of like, you know what? That's a good one to cover this week. So I decided to go ahead and run it, and it's just really fun. I think we're coming up on getting 100 myths, and that's gonna be, maybe we'll do a little celebration for the 100 myths when we crack it. We're getting close. It's probably about 4 weeks.
It was interesting because you had called me and told me about it, and I said, well, just tag me on it. And so I went over there and answered it. And of course, I had old Ted Fritz. He's arguing about everything. But one of the guys come on, and he said, thanks for explaining that and what the co-making panel's position was. And I even had the text that showed it. I'm going to do it when we cover it here. But
Okay.
and Ted Fritz come on and said there was no substantiation. I was like, you got to be kidding me! I just posted and told you where it was. And what was interesting is the change that they did was in the 2023 NEC, where it was one of the changes we covered. That's why I knew it was there, and
Okay.
it was to help clarify that, letting you know the equipment bonding jumper is a continuation of the equipment grounding conductor. So you're
Right.
creating that path just like, well, we'll get into it on a little bit, but
All right.
you
Well.
know, that was one of the things. And so I said, you know what, this is a good myth.
All right.
So
Well, let's freaking roll it.
it's queued up.
It's time for Myth of the Week.
All right, so the reason I pulled this one out, because, and it's really funny because, like, when you look at my picture, basically it looks like there's like a number 10 bonding jumper going up to that sheet metal screw. That sheet metal screw would probably be a code violation in the NEC, and a lot of people correctly answered that. And the thing is, this is probably a European install, so there's probably, they might be able to get away with that stuff. And it was funny too, James. I didn't understand what was going on with that other sheet metal screw that was coming in the side over there on the left-hand side.
Yeah, I see it.
But regardless, you can tell that basically all these conductors are made to one common point in this Wago wire connector. I'm not saying that's a Wago brand, but it's some type of a Wago design. But like I say, it looks funny to me that it looks like they actually tried to increase the size of that bonding jumper. Because it looks like all the conductors in there are smaller, and that bonding jumper looks to be a little bit larger. But regardless, we ran into this before, and like a lot of the stuff that's in 250 122B is kind of controversial. A lot of guys say, oh, well, it could just be sized from a qualified person, but the whole thing is, it's like, really, in all actuality, how is that really recognized by the AHJ? And that's always been kind of a little bit of a controversy there. A lot of people don't realize this. Basically, where it comes up and it like kind of rears its ugly head is when you get into like HVAC, and guys say, well, just to be safe, I'm going to pull a number 8. Well, now all of a sudden the unit comes out and it's 15 amps. Well, you're 4 times larger ungrounded conductor than you need that's adequate for that appliance. So now you have to upsize the equipment ground proportionately. And so that's kind of where a lot of these people get mad about this. I know we ran into this before with, a lot of times it's like number 10. So if you have like a number 10 NM cable, you're going to have a number 10 equipment ground in most part. I know there's probably is some NM manufacturers out there that probably do run a D-rated ground, like that's in for like a previous code cycle. But when you look at the current code cycle, what does the NM cable come out? It comes out with number 10 conductors with a number 10 ground, because that's what you need for 30 amps. So that's kind of where I see it, James. And when a cable manufacturer is producing their cable with a number 10 full-size ground in there, then that tells you that that's going to have to be, coincide with your bonding jumper as well.
Right. Just comment on the illustration. Looking at it, it looks on the far left-hand side of that illustration, there's a number 10 that's coming into it, and I think they're basing that equipment bonding jumper off the largest conductor coming in, and then the rest of them look like it could be 12s. That's what it looks like to me.
I agree with that. That's a good call.
Okay.
It's just hard to see any of the number 10s in there.
All right. Now, when you look at this, it's the answer to the question is going to be true. Now, there's more to it than just looking at 250.122b. When you get into this, you have to look at other sections. And the thing that gets me, and sometimes you may need to look at a code making panel substantiation to clarify a few things. But this is where we've gotten into a problem here lately, that there's some that are out there, they'll read something and just say that's it without looking at the rest of the code. And that's something I've said over and over and over. You have to look at all the code. You just can't pick one section all the time and say that applies, through the whole code. That's not going to work. So what I did here is I wanted to take a look at a few things right off the bat. Now, when you look at 250.109, it talks about the metal enclosures. Now, something we've discussed we did last week was about is the metal conduit and the metal boxes, everything, will that provide a better equipment grounding conductor path back? And the answer is yes. I've actually been to a seminar that was done at NFPA that Georgia Tech University came in, that was presented by Rich Boyd, and they showed the documentation. I saw it. I know for a fact that's true. So when you look at this, it talks about metal enclosures, and it says shall be permitted to be used to connect bonding jumpers or equipment grounding conductors to both together become part of what? An effective ground fault current path. Now, if you remember last week, we went over this, and one of the first things I talked about, I started where? In Article 100, and I started on the effective ground fault current path. And then I tied everything in from 250.4A5 and B4 and just, I went through the whole thing. That's sort of the same thing here. You've got to have an effective ground fault current path back. Now, the metal, the equipment grounding conductor going over there, and the equipment bonding jumper, that's all a continuation of the effective ground fault current path. So that means whatever you're going over there with, everything has to be sized accordingly. You cannot size down. Okay?
Yeah, and you think about it, and we were talking about this, like if you go out to like a junction box somewhere and you're pulling number 6, even though it's on a 20 amp circuit, you can't just all of a sudden drop to number 12 because it's on a 20 amp overcurrent device.
Sure you can. You upsize those conductors, and more than likely it was due to there's only 3 reasons it's going to be updated. Upsize. You're either going to have voltage drop, you're going to have a correction factor or adjustment factors. That's what's going to cause it. Okay?
Temporary.
Now, when you go over after that, then you look at the continuity of the equipment grounding conductors and attachment in boxes. Okay? Now, what it says here, a connection used for no other purpose shall be made between the metal box and the equipment grounding conductors. The equipment bonding jumper and equipment grounding conductor shall be sized from what? Table 250.122 based on the largest overcurrent device protecting circuit conductors in the box. Now, this is where it's interesting because they literally say here, well, if you read that section, you have to apply table 250.122 just for the bonding jumper. And it does, and 250.122B doesn't apply. And I said, okay, well, let's take a look, because this particular change took place in the 2023 National Electrical Code. Matter of fact, this change is in our publication. All right. Now, when you come over here and look at this, this is the first revision part that they did to 250.148. And this is, all I did was put the committee statement. And it says, changes made to this section clarify that all equipment grounding conductors in a box are to be connected to each other. This ensures that the equipment grounding conductor of any faulted circuit is routed with the ungrounded conductors of the faulted circuit. Then watch this. Language is added. Now, they added this so there wouldn't be this confusion, but of course you got people like Ted Fritz and them over at ECD that don't go and look at the committee statement to see what their intention is. But there's a reason they added this. and it's added to ensure the common bonding jumper to the box is sized to what? 250-122. It doesn't say table 250-122 because it's automatically assumed you're basing on the overcurrent protection device. But if you have to upsize it, it's all contained within 250-122. So therefore, 250.122B would apply in this case because it's a continuation of the equipment grounding conductor. All right?
Yes, sir.
So then when you come over here, here's your table, and just say you had a 20 amp and you pulled a number 12, but you upsized and went to a number 10 because due to voltage drop. Now you're going to have to make that equipment bonding jumper match that. And then when you come over and look at 250.122B, this will be based on the size of the circular mill. And I've done an example of this before, but if you look at this, the exception says equipment grounding conductors shall be permitted to be sized by qualified persons, and the exception to provide what? Looky there, an effective ground fault current path where we started in 250.109. And then I said, when you go look at that in Article 100, that ties you in with what? 250.4A5 and B4. And that's where it all has to be continuous and permanent and sized together. That means it's an extension of it, that equipment bonding jumper, because it is part of the equipment grounding path that provides that effective ground fault current path. Okay? Now, as an example, I've done this type of example before, but when they're looking at this and it says shall be, if you look at 250.122B, the last part of this, it says, if installed, shall be increased in size proportionally to the increase in circular mill area of the ungrounded conductors. Okay, now, let's say you got a 200 amp panel. Let's just say I'm taking a feeder over somewhere. Say I'm feeding another panel, and it's 175 amps. Even though I've got a 200 amp panel board over there, we'll just say we're taking over there with 2 alt conductors, which are good for 175 amps for 75 degrees C. So I go over there, I feed that panel, but now all of a sudden, due to voltage drop, I have to increase the size of that. Now, if I do that, say I did my calculations, I did the voltage drop last week and the week before going over those calculations, but if I increase the size of that, now let's say we increase it and we decide we need a 3 alt conductor. So what'll happen here is you'll go over to chapter 9, table 8, and you're going to pick up the circular mill for the 3 alt conductor and the 2 alt conductor. You're going to divide that circular mill in from the 2 alt to the 3 alt conductor, and that'll give you a multiplier. It's like 1.25683 or something like that. Then if I come back here and I look at this and I pick up 175 amp, it says I needed a number 6 going over there, right? For copper, all right? Now, what you'll do there is now you're going to go over, and I can tell you it's going to increase one size, but you go over and you go to chapter 9, table 8, pick up the number 6 circular mill, and then what you got on that multiplier there, you'll multiply that circular mill by that multiplier, and then you'll get your new circular mill and you'll size it, which would have came up to a number 4, because I think it's like 43,000, something like that. But it'll come down and it'll set it up that way, and that's how you do it based on the circular mill. Now, if I'm making it, if I go over to that panel board and say I had to make any bonding connections in there, what are you going to base that off of? You see what I'm saying? It is all part of a continuation. And that's why I say you do one to a box. You're doing it just like if I went over to a panel board, I might be bottom feeding it or whatever. You got to make sure the conductors are large enough. And to give an example, say if I go look at 250.32B1 and B2. Now, when it first come in the code, it was 250.32B exception. And basically what you could do, I could go over to another building or structure and I could use equipment ground over there coming back and a neutral. Now, if I didn't have an equipment ground, I could use the neutral as the equipment ground. But what happened in that case? It said that you need to take and determine what the size equipment ground is and what size the neutral is, and whichever is the largest between the two is the one you'll use for that path back. It's the same concept. If I go over there to another panel board and I'm feeding something and I got to bond everything in, you got to make sure everything is matching up, and then you go look at 250.102C. You see what I'm saying? There's a lot of it, and what they're saying does not consistently match with the other things that you do in the National Electrical Code. Now, I could sit here and go over all day just showing all these calculations, everything, to prove my point. But what I'm trying to say here is you can't pick and choose where you want to apply something. And I think this here is a good example showing that you create that effective ground fault current path, and it's a continuation of the equipment grounding conductor.
True. I agree.
Okay.
Yeah. I don't know why it has me on there as Facebook user. That's weird.
It doesn't show that there. It says
in the comments.
Oh, in the comments?
Yeah.
I don't know.
I'm just trying to check it out, but
Oh, no worries. All right. Well, I think everybody's probably ready for me to get
so
back
it
into
goes Stallcup. So yeah, we had a comment come in. And that's funny because this was argued a lot in there, and I like how James puts it, how he makes it simple to understand, you know. And so I'm glad you feel better about.
The great thing is you go through and you show examples and tie other things in other parts of the code, and you can see where that becomes a problem where you start picking and choosing. But I think the code making panel did a great job, and I think their substantiation was great because they did not state table 251.22. They said 251.22. That meant all the rules that apply in 250.122 apply, just not the table.
Yeah.
And if you actually look, when you go over and look at 251.48C, all they're telling you there is if you got an equipment bonding jumper over there, you size it the same as you would the equipment grounding conductor per what? Table 251.22. But it's still the same rules that apply. You know, that's why it gets me. Like, you got to do everything the same. But I think we proved our point on that pretty well tonight.
Yes, sir. So the myth of the week is confirmed. You do have to upsize the bonding jumper if you upsize the equipment grounding conductor. So awesome. Thanks for sharing that, James, and putting it together, and did an awesome job. Appreciate it.
No worries.
So I hope all you apprentices out there have your code books out, because we're going to get ready and start the exam prep.
Topic of the week, Journeyman Master Exam Prep. Here we go. Let's cue it up. All right, as always, we get started. You know anybody out there, they can catch the previous episodes we've done. We appreciate if y'all tell people about it, have them come over and subscribe. You know, it's amazing me because I look on there and I see how many views are on there. We don't have that many subscriptions compared to how many views. I think just the last month we had, I think we're up like 2,800 views or something, and these are all different ones. So, you know, at least subscribe. You know, we're getting it to you for free. I mean, so even if you don't ever come back and look at it, it's just a subscription that just shows we have people watching.
Hit that thumbs up and hit that subscribe.
Yeah, we appreciate that. All right, this week what we're getting into is finishing up. We went through all the box fill last week, and this was the homework portion here, and we're going to be looking at the round optical boxes, and we'll get into the device boxes and square boxes and then other boxes. And then we'll start calculating for the rest of the wiring methods. And when we come back next week, we'll go through that. Then we're going to start doing calculating conductor ampacities. And we're really going to start getting into the meat of where most people have the problem with calculations. But don't worry, by the time we go through, you're going to be like, this is not hard once you understand what you're looking for or where to go. It's just like these box fill calculations. Last week we went through the start of it, talking about the method of that you will do in order to count the conductors. And that's what we're going to reemphasize here this week. So if I look at this, you'll notice in the illustration we have a canopy. Now, if I have 4 or less wires and are 14 or less in size, then I don't have to count those conductors. So you're going to see here we got number 18 wires for our fixture wires. So we're not going to count that, okay? Because we do have the canopy. And that's over in 314.16B1 exception where you're going to pick that up. But now I've got 2 number 12s coming in, 2 number 12 ground and neutral conductors. I have 2 equipment grounds, so I don't have more than 4, so I got to count at least 1. I have a fixture stud and hickey. I got to count 1 for each one of those. So if I look over an exercise problem, you would be looking, we went over this last week, you'd be looking over at 314.16 B1 through B5. If I have 2 number hots, that's 2 conductors. 2 number 12 neutrals, 2 conductors. 2 number 12 equipment grounds didn't exceed 4, but I got to count at least 1, so that's 1 conductor. Then 1 conductor for the fixture stud and hickey, 1. And then, of course, I have a canopy, so I don't have to count any of the fixture wires. Add that up, that gives you 7. Then I go over, look at table 314.68, pick up the number 12s on the top right-hand side, come down the next value above those 7 conductors. You come across, look to the left, and it's going to tell you for a round or optical box, you need a 4-inch by 2 1/8 inch box. Pretty simple. And that's what makes this great is you can see by following along, once you understand the counting of the conductors and you know where the tables are, where you pick the sections up, right here, it doesn't get any easier than this. All you have to do is remember, if I'm doing any type of box fill calculations here, or I'm doing any type of pulls, I'm going to be dealing with any type of conduit bodies, all that stuff's going to be in Article 314. The sections you always want to concern yourself with are these: 314.16 B1 through B5, table 314.16A, table 314.16B, and 314.28A1 and A2. As long as you've got all of those, you should be able to follow along with this very simply. Now, the second part is different size conductors. Now, we got 1 number 12 hot. This is actually a simple one. We got a number 12 ground and neutral conductor. We have a number 12 equipment ground, and we have 2 number 16 fixture wires and 1 number 16. Now, you'll notice in this, and there's no canopy. Okay? So if I look at the different size conductors in step 1, where we always start is 314.16 B1 through B5 for the method of counting our conductors. And now, since they're different size within the same box, I need to look at table 314.16B. That's where I'm going to get my cubic inch rating for each one of those conductors. And for number 12, it's 2.25. Okay? So you got 1 number 12 ungrounded phase conductor, 1 number 12 grounded neutral conductor, and 1 number 12 equipment grounded conductor. 2.5, 2.25, 2.25, and 2.25, A, B, and C. Now you're going to look at the fixture wire. You go over, look at table 314.16B, it's going to tell you it's good for 1.75. You multiply that by 2 because you got 2, that's going to give you 3.5. I've already counted for one of my equipment grounding conductors. You only got 2 in the box. You didn't exceed 4, so you'll get a 0. Add all that up together, you get 10.25 amps. Come down, look in the third column that's there. That's where your cubic inch rating is. Come down, look at the value that exceeds 314.25. Come across, it's going to tell you the box size needs to be a 4 inch by 1 1/4 inch round box.
So on just a quick question. So that box size should be in a table that's in 314, right?
It'll
So
be
you
in
should
table.
be
It'll be in table 314.16a.
nice. So you should be able to just go right over there, look at the table, and then find it. The other thing that I would add to this is, man, if my apprentice made up a light like that, I'd be like, "You're gonna leave it like that?"
Oh,
I don't know, man.
we just put it we just put it like that because we're trying to show there's no canopy. It's
Oh, right.
it's
That's funny.
more, it's not a full installation. All we're trying to do there is get the conductors out so you could see the conductors and how to do the conductor
True.
fill.
No,
It,
it's a good illustration. I was just joking.
sometimes it's hard when you're doing these illustrations because you've got to have enough room up there to show exactly what it is you're trying to calculate. And
Right.
if you do it as a full installation, well, then you can't see what wires are there.
Yeah.
When we're looking at this, we're mainly thinking to ourselves, we want them to be able to see what's here, and that's why we spend a lot of time putting these together like that.
I'm
Okay.
actually surprised the box screws are still in there. Usually they fall out.
Yeah.
So.
Okay. Now look at this. Here's a device box. The same thing. I got 2 number 12 hots, 2 number 12 neutrals, 2 equipment grounds. Now remember, we have a receptacle. If there's any device there, we have to count 2 conductors for each device. And then if you have a
Right.
bonding jumper, it's in there. We don't count the bonding jumper. Okay.
Right.
So if I look at my same size conductors in step 1, you got your 2 number 12s, ungrounded phase conductors, 2 number 12 ground and neutral conductors, 2. You got 2 number 12 equipment grounds, 1. You got 1 receptacle, count 2 conductors. Bonding jumper, count as none. Add that up, that gives you 7 conductors. Go over to the top right hand side of table 314.16a. Pick up number 12, come down the next size above 7, and look over to the left for device boxes, and it's going to tell you need a 3-inch by 2-inch by 3.5-inch device box. Okay. Now, the interesting thing I like to say about this, if you notice, I have not changed the calculations at all. I'm still in the same sections. I'm doing everything the same. The only thing I'm doing is when I get over to the left-hand side of table 314.16a, I'm either looking at round or optical boxes, I'm looking at device boxes or square boxes. Okay. Now, the next one is different size conductors, the same calculation. You'll see we got 1 number 14 ungrounded phase conductor. I got 1 number 14 grounded neutral conductor. Now, this is the one you need to look at here, because if you look at the illustration, we're showing you the number 14s are passing through and the number 12s are connecting to the device. So that's going to tell me right there when I take the 2 conductors for that device, that's what's connecting to it. So I'm going to base it off of that cubic inch that's connected to it. So we'd base it on the number 12s, not the number 14s. Okay. So when I go down, I've got 1 number 12 ungrounded phase conductor, 1 number 12 grounded neutral conductor. I have 2 number 12 equipment grounding conductors, 1 receptacle, and a number 12 bonding jumper. So I'm going to come over and decide what I need here. Now, if I look at table 314.16b for a number 14, that's going to give you 2 cubic inches. So 2 and 2 for the hot and neutral. Then I've got the hot and neutral is a number 12 that's connected to the device, and table 314.16b says the cubic inch is 2.25. So I'm going to add that all the way down, and I got to count 1 for my equipment ground, which is 2.25. Then you take the receptacle, the number 12's connected to it. So I'll take the 2.25 times 2, and that's going to give me 4.5. I get a 0 for the bonding jumper. Add all that together, gives you 15.25 cubic inches. I'll go over, look at table 314.16a, come down the third column in the cubic inch, find the cubic inch that's above the 15.25, And that's going to tell you for the device box, you need a 3-inch by 2-inch by 3.5 inch. Okay.
Nice. So you actually count those ones passing through as one each, right?
Yeah, just one each. And then
Okay.
where it's connected to the device will be based on the conductor that's connected to it.
Gotcha.
Okay.
Okay.
Now,
Cool.
I will point something out, since we did this earlier, that pigtail that's going over that you're using as equipment bonding jumper, that will not be a number 14. That'll be a number 12.
Gotcha.
Okay. Because that's what's connecting to it. All right.
Right.
Now,
Gotcha.
this is where you get into a square box. Now, what I like to point out, now we got cable clamps here, and looking at 314.16B3, we did this the other day, and you're going to need one count for the cable clamps that are there. Okay, they're internal cable clamps. Now, as I look at this, you'll notice we have 4 equipment grounds. I'm only have to count one, but if I had 5, 6, 7 in there, then I'd have to take and put a quarter on that. So I'd have to multiply the additional by 0.25 like we did last week. Now, I've got 4 number 12 ungrounded phase conductors. I got 4 number 12 grounded neutral conductors, and I have 4 number 12 equipment grounds, and I have 2 cable clamps. Now, there is something I want to point out here. This will be a trick on the test. Anybody watching this needs to pay attention to what I'm saying right now, because when you get over there, you're going to start to see that when you get into sizing, there will be different size boxes you can get in there. And you may look at one that'll fit, but remember, they're going to take what is the minimum one there. Okay. So in this case, if I look at this, instead of it being a 2-inch by 1.25 inches, let's say, instead it ended up being a 4/11/16 by 1.25 inches. That's going to be the smaller box that could be put in there. Okay.
Right.
And you have to go and look at that, because that's going to be over there. And it's funny because I caught this, God, I guess it's about 25 years ago. And I was going through the calculations and everything. And I went in and asked Dad, and I said, if I'm looking at it, he goes, you know what? He said, we got a mistake there. He said, but I want to leave it the same. He goes, that's a good teaching point, because on the test, if they put the minimum size box, that's what you're going to go with. He goes, that would actually be the correct answer. Okay. So I just wanted to point something like that out, because more than likely somebody probably put a different box size here, but actually this was the minimum size.
Well, and that's a good point too, James. That's a trap that a lot of these apprentices have to watch out for. That they're not just going with a little bit larger just in case. Because I was kind of doing that. I remember that when I was taking my test, I was like, oh, I should be covered if I go with 2 sizes up, But they put the 2 size up one on there as one of the answers. And you think, oh, cool, I got the right answer, but they want to know what the minimum size is.
That's right.
So,
and that's why we have certain calculations in here that way. So you go in and you see why we did what we did. Because, the main thing, we want people to pass, but you need to know all the tricks that are there. Yeah. And that's why we have it in here like this. But anyway, so I had 4 ungrounded phase conductors, 4 conductors, the neutrals 4. I had 4 equipment grounds. I don't have more than 4, so I got to count 1. I had 2 cable clamps. I had to count 1. That gives me 10 conductors. Pick up your number 12, come down the next size above that, look across, and it's going to tell you the minimum size there is a 4/11/16 by 1.25 inch square box. Okay?
Right.
Now, anybody that's watching this, you'll notice, have I changed my calculations any? No, it's just based on the total count and whether it's same size or different size conductors. I'm still following the same format I started with. So if I look here, the same thing happens. I've got different size conductors here. I've got number 12s and I got number 14s, and I got 2 cable clamps. I'm just going to do the exact same thing here. I'm going to come down. I've got number 12s, if I look at table 314.16b, that's good for 2.25 cubic inch. I'll multiply that by 2. That's going to give me 4.5. The next one, ungrounded phase, or the grounded neutral conductors, 4.5. I've got 4 equipment grounds in there, but I only have to count 1, and the largest is a number 12, so I have to take 1, so that'd be 2.25 cubic inches. And then I got 2 number 14 ungrounded phase conductors and grounded neutral conductors. Well, if I look at table 314.16b, the number 14 is good for 2 cubic inches. Multiply it by 2, you get 4 and 4. You don't count the number 14 equipment grounds, you get 0. I got 2 cable clamps, I have to count at least 1. That's 2.25 cubic inches. Add it up, gives you 21.5 cubic inches. Come down the cubic inch column, come all the way over to the left-hand side, pick the cubic inch that's above it, and I'll tell you the size square box you need, which is a 4/11/16 by 1.25 would be the minimum.
Yeah, and this is an interesting one too, because this would kind of coincide with our myth. So you have 2 different overcurrent devices in this. You have a 15 amp overcurrent device and you have a 20 amp overcurrent device. So your bonding jumper would be sized off that larger size. So
that's correct.
Your bonding jumper would be number 12.
That's correct. That's exactly correct.
Yeah.
All right. Now, this is where you get into the other boxes, and I said you'd have to use the chart or go online and look at the different sizes, where you'd have a 4x4x4, a 6x4x4, 6x4x6, 8x6x4, something like that. Now, this, and we've got 8 number 12. All these are the same size. We got 4 of them that are 8 number 12s, and we got 2 that are 4 number 12s. So all I'm going to do is add all these up, and I'm going to do this in circular mill when I'm doing other boxes. You're not going to do just one conductor for each, because I need to know what the cubic inch fill is, because I'm going to have to size my box by the cubic inch. And we went over this last week. So if I look at table 314.16b, the number 12, once again, is 2.25 cubic inches. I've got 8 of them. I'll multiply that. That's going to give me 18 cubic inches for those first 4. Then I go down and I've got 4 of them. So I take 2.25 cubic inches times 4. That's going to give me 9 cubic inches. Add all that up together, gives you 9 cubic inches. And then you take 6 times 4 times 4, and that'll be the next size that's up above that. Let me look here. Let me see if I got my calculator here. I'll tell you exactly what that value is.
So I want to bring up something real quick, James, and I think it's funny how this illustration kind of helps me talk about this. And we've come into this new myth that a lot of people talk about, where they're saying that you don't have 6 inches of free conductor in that illustration, you know. Mm-hmm. But running a pigtail with that splice in there is actually compliant for your 6 inches of free conductor.
Sure.
So a lot of people don't know that, and a lot of people think, oh man, you have to have 6 inches of free conductor from the back of the box, and there's a bunch of arguments that came off of my last post. So I really appreciate all the comments that everyone gave me, and kind of gave me a little idea of what kind of myths that I need to cover moving forward, so that we can bring these up. But that illustration kind of shows it, that it's compliant as long as you're able to splice. You can even shove that back in the knockout. Remember that one?
Oh yeah, I do. And that cubic inch was 96 cubic inches, so it was just right above 90 cubic inches for that size box.
Nice.
So now the great thing is, if you notice, I have not changed the way I do these calculations. I keep saying it over and over. I want people to understand you're not changing anything. You're just different applications depending on what you have here. Now, this one, I've got 8 number 10s. I got 10 number 8s. I've got 12 number 12s, and I got 5 number 6s. Now, this one, we put a note in here. We're not doing any equipment grounds here to keep it simple, so people understand how to do the or to get their cubic inch fill. But now if I had equipment grounds in there, you're going to have a lot of equipment grounds. And we did a calculation the other day on this, showing where you did have the equipment grounds, and we showed we showed 20 extra in there. And then we showed doing that at a quarter and taking it at 0.25 and adding that additional count on there. Okay.
Right.
Now, this one here, if I go over and look at my 8 number 10s, well, what is number 10 good for? Well, that's good for 2.5. So if I take 2.5 per table 314.16b times 8, that's going to give you 20 cubic inches for the first two. Then if I got 10 number 8s, what's a number 8 good for? It's 3 cubic inches. So 3 times 10 is going to give me 30. I go down to it. Number 12 is good for 2.25. I got 12 of those. Multiply by 12. That's going to give you 27 for the next two. And then your number 6 is good for 5 cubic inches. So I'll take 5 times the 5 that I have there. Gives me 25 for the next two. Total that up gives you 204 cubic inches. And then if I take and I do 8 times 8 and then multiply that by 4, that's going to give you 256 cubic inches, which will contain the next size above that. Will contain that 204 cubic inches. Now, that sort of wraps us up just on box fill. And hopefully everybody has a good understanding now how to do the box fill and maintaining the same step-by-step calculation. Basically what it comes down to, if you understand how to do step 1 for same size conductors and different size conductors, then you can lay everything out properly. Okay?
Yeah, and the one thing I like about this is like it's easy for us to show kind of like these younger guys like in the field. So like if we were to go and take that same illustration and just pull those conductors right straight through without splicing it at all, you wouldn't even need to splice any equipment grounding conductors.
No.
So a lot of that gets it makes it easy for us to teach when we're able to show these illustrations that James put together and show that, hey, we could do this, we could do that. Like there's been times before where at the end of the show, James and I just sit there and just do illustrations and and I'm like, hey, just do this color, use this, you know. And so it's a lot of fun to be able to express what we see out in the field and be able to show you guys how you can see it on a test. And when you see it on the test, you're going to know it on the test.
That's right.
That's the important part.
Well, and one of the things that we like to do, and I don't think the other publications actually do this. I'm not 100% sure on it. But you'll notice we do round and octagonal, then we do device boxes, square boxes, and other boxes. And if you notice, all the calculations, it doesn't matter which box you're doing. It's still the same calculation. It's just knowing the methods of counting your conductors. Once you got that, if you do multiples of these, and all of a sudden it clicks for you. Just doing 1 or 2 compared to doing 8 of them, and then that includes looking at the example problem that we do for them. You get 16 different types here to look at on how to go about sizing it, and it's the same calculation, just different type of box. That's it.
Right.
All right.
Yeah, and I really like that, how you put them together.
Yeah, it takes time to do all that, but I think it's worth it in the end. Now, this is possible, could be on your test. They may want to know if you know how to do what the cross-sectional area of a conduit body is. And this, and we're going to show where you're connecting to a 3/4 inch electrical metallic tubing. Now, if you go over to chapter 9, table 4, and you pick up a 3/4 inch EMT raceway, it's going to tell you that square inch rating there is 0.533 square inches. And then all you're going to do is just multiply that by 2, and that's going to tell you what the cross-sectional area of that LB is, which would be 1.066 square inches. It's a simple calculation. It doesn't take any time to do. You just have to remember where to get the square inch value from, and that's going to be in chapter 9, table 4, based on the type of conduit system you're using. Okay?
Right.
Now, next week, we'll go over this, but you'll see in this particular one, we got a 1-inch LB here. Okay. And we got the LB. I think they did a really good job drawing the LB to show what it looks like and everything. And you'll notice we've got everything set up here for you to look at. The known values are here. We're telling you the type of conductors, but the main important part is we have a 1-inch EMT. Okay.
Right.
You'll go over and get that information. We even put in little calculation tips in here that give you some of the things to think about how we're going about sizing that. Okay.
So we went into a really interesting myth. You guys will have to look back at our other episodes where there was a certain code guy that said you couldn't splice in an LB. And I went and found one that was like 94.2 cubic inches. And I mean, you could splice like 41 number 14s or something in there. Like it was crazy. Like when I saw it, I was like, wow. I was like, this thing's like a junction box.
Well, isn't that funny? You look up there, you see right on the right hand side of the illustration, we show it being spliced right there.
Right.
You see the wire nuts there. The reason we do that is because that's why you need to know what the cross sectional area is, and that's why we have it in there. And 100%. And some say you can't do it. Well, yeah, you can. It all comes down to you have the space in there. Now, this is not going to take that long. You're going to be looking at 314.28 A1 and A2. Now, if you're looking at A1, this is where we're going to deal with straight pulls, and when I get to A2, this is where you're going to deal with angle or U pulls. Okay.
Right.
Now, the first one's very simple, and this is what you need to remember. If it's a straight pull, you multiply by 8, and it doesn't matter how many conduits are added on there, it's still going to be 8. Now, if I have an angle pull, your multiplier is going to be 6, and you'll multiply the largest conduit by 6, but you have to add the others to it. Okay?
Yeah, we always say, like, when we're out in gas and oil, like, straights are 8s, tricks are 6.
Yeah. Now, if I look at this, I've got one run a 2-inch raceway. So my multiplier per section 314.28A1 is a multiplier 8. So you just take the 2-inch raceway, multiply it by 8, and it tells you the minimum length of that pull box has to be at least 16 inches. Okay? Yeah. And then you'll get your illustration here. And we're going to be doing a 3-inch. This is simple. You know it's an 8, 3 times 8. You shouldn't miss this. I'm not going to tell you the answer. Anybody knows how to multiply and knows what that answer is. And then if I come in here and I got a straight pull, I got a 4-inch, 2-inch, and a 1-inch raceway. Okay? Now, you're only going to take the largest one and multiply it by 8, and that's going to be your length. You don't add the rest of these to a straight pull. Okay? So I take the 4-inch raceway times 8. That's going to tell me I need to have a minimum length for that pull box there of at least 32 inches. Okay? And then you'll see here, this one's going to be a 4-inch. And you're going to see we did it on purpose. We put E and F there in the exercise problem. You know those are going to be 0. Okay? But the reason we put them in there because we wanted you to pay attention that you're not going to add the 2-inch and the 1.5 inch there. You're just going to put a 0. Okay.
Wow, I didn't know that. That's a good one.
Yeah, I mean, there's reasons we do what we do, and some of this is due. You're talking 80 years experience, probably really close to getting to 90 now, of things Dad and I have taught over the years, and watching what people do and what they get wrong, and then we just started doing things that we saw they were doing wrong, added it into the illustrations, and then if they put it there and then they check the answer key and see they got it wrong, they're like, oh shit, that's a straight pull. I don't want to put nothing on that. It's just one time.
Well, and I think it eliminates the Z-axis that some of the other educators put in their illustrations.
Oh, I know you're talking about there. All right. Now, here's an angle pull. I said the multiplier is going to be 6. In this case, I've got one run that's 4 inches. So I'm going to be coming at an angle. So I'll come from we'll or to say I'm coming from the right side of the box to the bottom side of the box. So I'm going to angle over to that pull. So in order to have enough length in there, I'm going to multiply that by the multiplier 6. So I'll take the 4-inch raceway by the multiplier 6, and that's going to tell you the minimum size of that box. It's just not for the straight. This will be the whole box. I have to be 24 inches by 24 inches because you're making pulls connecting from one side to from the side to the bottom side. So you need to at least have enough area in there to make that pull for the angle. So it'll be 24-inch by 24-inch box. Now, this in here, we're just doing a U-pull. It's a 3-inch, okay? All you're going to do is take the 3-inch times what? 6. So you should easily know what the minimum length of the box should be here. All right? Now, when I get to an angle pull that has multiple conduits connected to its side, so say I'm on the right side of the wall of the box to the bottom side of the box, we've got a 4-inch, 3-inch, 2-inch, and 1-inch. So you're going to take the largest one at the multiplier 6. That's going to give you 24 inches. Then you add the rest of them together. So I got the extra conduits I have a 3-inch, a 2-inch, and a 1-inch. That's going to give me 30 inches when I add them all together. And that'll tell you the minimum length has to be 30-inch by 30-inch box. Same thing when you get over here to the next exercise problem that you're going to work for your homework this coming week. You got a 3.5-inch, a 2-inch, and a 1-inch. Okay. And you'll just take the 3.5-inch by the multiplier 6 and add the rest of them together. And you'll notice in step 2, we have E and F in there. So you'll add those additional. Whereas if I was in the straight pull, I didn't add those other conduits. I only do it on an angle or U pull. Okay. And that gets you through your pulls as far as having a junction box. So you got the straight pull and angle pull. Then
Nice.
what you're going to get into is sizing your conduits. Now, most learn this right away, but if you're going to take and all the conductors are the same size, you're going to look at Annex C. And then you're going to look for the type of wiring method that you're employing. At this point, we have an electrical metallic tubing, so that's going to be table C1. And all I'm going to do is go over there, and I'm going to pick up the number 12, come down, find the size that's above the 10 number 12 conductors come across, and it's going to tell you that a 3/4-inch conduit will contain those 10 number 12 conductors. That's about as easy as it gets right there. And then you come over here, we got 4 number 6, okay? And if you look, we're using rigid metal conduit. Now, when you get in and you start looking at this, make sure that you go over and you look at Annex C and you find the exact table that you're going to be dealing with. And then you're going to come across and look at the type of conductor, because if you get the wrong type of conductor that's in there, this is a THWN. If you use XHW, for instance, or something like that, you're going to get a different, the possibility is you're going to get a different answer. So make sure you're picking up the right type of conductors and how many are in the raceway, then come down, come across, and it'll tell you the size that you need. Now, when I get the different size conductors, we're doing one here that's electrical metallic tubing. The 2 sections you need to know here is I need to go to chapter 9 and I need to go to table 4 and table 5. Those are going to be the 2. Now, in order to get the square inch of the conductor, you want to remember you're looking at chapter 9, table 5, and make sure once again that you pick up the exact type conductor that's being used. Okay, because there's going to be a lot of different types of conductors in that table. In this one, we're using THWN. So in step 1, if I look at chapter 9, table 5, and I pick up the THWN copper conductors and I come down and I pick up a number 4, it's going to tell you the square inch value is good for 0.0824, For the number 6, it's 0.0507 square inches, and the number 8 is 0.0366 square inches. Now you come down, we had 2 conductors for the number 4. We had 1 for the number 6 and 1 for the number 8. So I'll take for the number 4, 0.0824 square inches times 2. That's going to give me 0.1648 square inches. And then I just had 1 for each. So I'm just going to bring the value of 0.0507, 0.0366 square inches on there. And then I'll add that up. That's going to give me 0.2521 square inches. Now, once you get that, you've got all your square inch value here for your different size conductors. And then I'm going to go look at Chapter 9, Table 5, and you're going to look at the column where you have over 2 conductors there. Okay? So I'm going to come down to that column, find the next size that is above that 0.2521 square inches, which is 0.346 square inches. Then I come across and look, and it tells you you're going to need a 1-inch EMT for that installation.
Yeah, and just to add to this, James, I really like how you put this together. You guys can double check yourselves. Like if you're really confident on this kind of stuff when you're in the test, you can actually see if some of the numbers aren't really jiving for like the answers. Like you're like, hey, wait a minute, there isn't even 1-inch EMT even in the answers. You know what I mean?
Mm-hmm.
Then what you could do is go back and kind of look at this and go, hey, how many number 4s did I have? Hey, how many number 6s? You know, so you can look at it, and that's why I liked how James has it set up, because when you know this really good, when you're in the exam, there's no pressure. You're able to just look at these numbers of these circular mills, and you're like, wait a minute, you know, this is not even on the chart. You know,
Yeah,
what did I do wrong? So you can kind of go back, you can reverse double check your question fast, because you know it. You know right away, this doesn't make sense.
Sure. And if you look, when we started designing the wiring methods, it's funny because when I was doing box fill, it was based on what? Same size conductors or different size conductors. When I get over here to the conduits, what is it? Same size or different size conductors. You just got to know where to go get the information. And that's why I say, if I'm doing boxes, you should get to where you know this. You should know I'm looking at 314.16 B1 through B5, and my tables are 314.16A1 or 16A and table 314.16B. If I'm doing my raceway systems, then I'm looking at Annex C for same size conductors, different size conductors. I'm looking at Chapter 9, Table 4, and Table 5. You should, when you go in, you should know that. And if I'm doing a pull box, then you know your 314.6 or 314.28 A1 and A2. And you know, when I remember when I went and took my test, I had all those sections in my mind before I ever walked in. I knew where to go if I was asked that question. But I remember taking my test, I didn't get this question, but that's okay.
Right.
And then you look here, we got 12 number 14s, 4 number 12s, and 4 number 10s. All you're going to do, we actually took in step 1, gave you the square inch of each one, and you go over and look at them, and then you'll see which conductor matches up with them. Then you go to step 2, add the number you have, get your total square inch, and all that's based on Chapter 9, Table 5. And then when I select the conduit, it's EMT. So you're going to look at Chapter 9, Table 4 for the EMT, and it'll be for over 2 conductors, which is 40% fill, which we show you there on the raceway in the illustration. Okay?
Right.
All right.
I like it.
Then the next one we get into is where you have a nipple. Okay? Now, we've discussed nipples before. That's something that's 24 inches or less. And in other words, it's not considered a raceway. Okay? So it doesn't matter how many you have in here. Since it's 24 inches or less, you don't have to concern yourself with the rating factors here. Okay? So we're going to decide what size nipple is required to enclose 36 number 12s. Okay? This is very, very simple. Okay.
Dude, you need to let it go, man. Willie got 25 number 12s in that 3/4 inch, and just let it go. I mean, that's just amazing. Nobody's gonna do that again.
Well, one of the things we did is to sort of come in and show everybody how all this actually works, and
Right.
we even show you uh, uh, when you're finding EMT at 100% fill, and if you look at it, it'll tell you how do I know what the fill is for 100%. Well, if you go over and look at chapter 9 table 4, it'll tell you it's 0.864 square inches. Well, the formula you would use to determine that is you'll take the diameter squared of the conduit, and that's also in the table, which is 1.049. You multiply that twice, basically you square it, and then you take it at 0.7854, and that's how they get the 0.864 square inches.
So
Okay.
I'll tell you in confidence. Willie kind of told me the secret on this one when he was doing this, but he says 77% is the most you could ever get in any conduit. He says 77% is 100% fill. So I don't know how he's doing that math or whatever. I think he was using soap or like some kind of weird fish tape, or I don't know what he was doing, but he said he could only get 77% max fill.
He's doing some good guesswork, man.
I don't know. I'm telling you, he said 100% is impossible.
Okay. All right.
Okay.
Now, let's look what can contain. Now, I'm going to tell you, this is the way we used to do the calculation, but now you can actually go over to chapter 9, table 4, and it'll have the 60% fill that shows you what that square inch is. Before they did that in the table, which was what, 3-4 cycles ago, you actually had to perform this calculation per chapter 9, and you would look at table 1, and then you would look at note 4, and you would have to know how to take and get that 100% fill. And this was based on the information that was in table 4, and you'd square it and put that 0.7854 on there to know what the square inch was in it. Okay.
Right.
So now when you look at this is how they do this, or this how we used to. If I go over look at chapter 9, table 5, and I pick up number 12, it's going to tell you for THWN that it's good for 0.0133 square inches. I multiply that at the 36 that I have in that neutral. That's going to give me 0.4788 square inches. Well, now, if you look there, we did the total fill percent, and we're telling you it's 0.864 square inches. If I take that at 60%, it's going to tell you here for the 1 inch EMT, which 3/4 would have been too small because we did the calculation. It'll give you 0.5184 square inches that will contain that 0.478 square inches. Okay. And then once you get that, you know that the 1 inch EMT is good to be used for the nipple at 60%. Okay. Nice. And I'm not sure if anybody shows that in their publications or not, how they squared this back here. But we've had people ask us, how did you get that? And then we go through, show them how to do it. And they're like, well, hell, that makes sense. Sometimes you got to go through that stuff to know what you're getting into. And then the next one you get, wait a minute.
Yeah, I think you need to add straps on your nipples, brother. You got floppy nipples in there.
What did I do here? Oh, okay. I'm right. Okay. I was looking at something else. Okay.
Yeah, see, there's a floppy nipple in there.
So
you can't have
you got your nipple here. We're showing you 60% fill. Now, if you look back at your old, when we were just doing conduit fill, it was at what? 40%.
Right.
Okay. This one's at 60% because it is a nipple. And remember, the nipple is 24 inches or less. You can go look at chapter 9, table 1, note 4. It'll tell you all that. Then you're going to do all your square inches, add them all up and everything here, and then you're going to determine what size raceway. We've already set it up for you. We're telling you need to look at the one that's 2.036 square inches here. So if you need to come up with that value. So you do some calculations, you'll figure it out. And then we'll go over it next week, and I'll tell you what size it was and what you need to do and all that. But
Nice.
same calculation. We're showing you how to do all this, and you'll fill that out as your homework next week. Then you get into an auxiliary gutter. Now, same concepts here. This one, I've got different size conductors here, so I need to go to Chapter 9, Table 5. And if I've got 3 350s, I got 3 1/0, I got 3 number 1s and 3 number 2s. Go get your square inch value. For the 350, it's 0.5242, 1/0's 0.1855, number 1 is 1.562, and number 2 is 0.1158. You'll take all of those, multiply them by 3. We had 3 in each one. Get all your square inch area, add it up. It's going to give you 2.9451 square inches. Now, the thing I want to point out, just like I did for the raceway, I did for a nipple, I had to go get all the square inches and just add up what was there. I'm still using the same sections here.
Right.
Then I'm going to determine, since it's an auxiliary gutter, I need to determine based on 20% fill here what I'm going to need. And you're going to look at 366.228 to get this information. So if I come back here and I look at this here, here's my square inch total value here, 2.9451 square inches. I'm going to take that and divide it by 20%, which is going to give me 14.7255 square inches. Then you're going to look at the box that'll contain that. So in this case, it's a 4-inch by 4-inch, which has a total cubic inch area there of 16 square inches. Okay?
Right.
Now, that they may ask you on this test, we're not sure if they'll do it or not, but they may ask, well, what if I get in and I want to know what I can use as far as my splices in that area? So all you would do is take that box at 75%. That's going to give you 12 inches, square inches. So we're telling you here that the metallic gutter is required with only 12 inches of gutter space used for what? Splicing conductors.
Yeah.
Okay?
And the one thing I want to tell all the apprentices out there is if you're confused on this in the test, just mark this for review and then go look at the actual definition. So, like, that was one thing that I did kind of wrong when I took my test, was I kind of panicked and I didn't know what something said. I didn't know what it was, and I kind of panicked and I guessed. And, like, you can't guess because the reason you don't guess is because you have guys like James Stallcup who are actually putting the wrong answers on there. And you have to know the right answer. So you have to know what these definitions mean, know what auxiliary gutter, like if you go in the definitions, you'll see there's auxiliary gutter, there's trough, there's wireway, there's all these different definitions in there. You have to know exactly what you're dealing with. So don't just assume that a gutter is a trough or a wireway is a trough or a trough is a gutter, whatever it is. I think in your case, James, in this, that a gutter is a gutter, but like, that's a hard thing. Like if you go look at Merriam-Webster's gutter definition, it's gonna tell you it's on the side of your house. You know what I mean? It's hard, it's confusing, and no, we're not trying to confuse anybody. We want you to know the truth and get it right the first time.
Sure. I'd look at an auxiliary gutter just like I do a wireway. You still got to size it the same.
True.
So,
and if you look at the definition, it says like an auxiliary gutter is a trough, or you know what I mean. It's confusing, and so it's hard. You have to know that you're talking about the same thing, so you could cross-reference yourself while you're taking the test. If you know all this and you say, "Hey, I just want to go look at the definition, see what a wireway is, what a gutter is, what a trough is," you know, stuff like that.
And especially when you're taking code, one of the things I always tell everybody, know your terms and definitions, because all you got to do is look in the back of the code book and it'll tell you what page auxiliary gutters are on.
Yes, sir.
All right. And then here's your homework for next week. And this is covering the auxiliary gutter here. And you just go through, work it just exactly the same way. You're still doing everything based on what? Square inch. And then when you take, just remember when you have an auxiliary gutter, once you get the total square inches, you divide by 20%. That's it. Okay.
Right.
And if they ask you how much square inch of the gutter can be used for splices, then you're going to multiply the box square inch, once you know what it is, by 75%. Okay.
Right.
All right. And then the last one we're going to do today is where I have a cable tray. Now, there's a lot of different cable trays we could done, but this is probably, if one gets asked, this is what they're going to ask. So we didn't do them all because there would be, you're probably looking at probably 12 different calculations we'd have to do for all the different types, because you get into communications and the large ones versus small ones. I mean, there's a lot of stuff you got to do there. But this is a normal question they would ask. It'd be based on a ventilated cable tray. And this case, we're going to show you have 12 250 case of meal and 8 1000 case of meal. Now, all you're going to do, like we start everything off, is you're going to look at Chapter 9, Table 5. You got to get the square inch of each one of those conductors. Okay? So for 250 case of meal, it's 0.397 square inches. For 1000, it's 1.3478 square inches. We had 12 of the 250, that's going to give me 4.764, and we had 8 of the 1000 kc meals, going to give me 10.7824. Add all those up together, gives me 15.5464. Then what you're going to do, you're going to look at table 392.22B1, pick up column 1, and it's going to tell you the next size above that's going to be 19.5 square inches, which is going to require you to have an 18-inch wide tray. Now,
Okay.
the thing is, I like to point out here, if you notice, everything's still the same. It's just you got to get those square inch values, get the total, then you guys got to know which tables you go to in order to apply the proper section there to do your sizing. So here we got 10 1000 and 14 300 kc mil. Going to do the same thing, get all your square inch value, then you're going to go over, look at the table, come down, the next square inch size above that, then it'll tell you what that cable tray size is going to be. Okay.
Nice.
And that will do it for the wiring methods. And next week, we'll be getting started on the calculating conductor ampacities. And I will tell you from this point out, that's probably the easiest of everything we've done up to this point. We've done all the pretty much easier stuff in my mind. Once we start getting the conductors and overcurrent devices, residential full calculations and commercial full calculations, you're going to have to really start looking at your code book, because there's a lot of sections we're going to be going through. But we'll try to keep it in the easiest step-by-step format and procedure possible. And I think based on what you're already seeing, you can see it's laid out in a systematic way for y'all. So that's it for tonight on Topic of the Week.
That's awesome. So we have a special treat for everyone tonight. I know it's kind of impromptu, but we have an unboxing. I think James will appreciate this. I'm using we did a review a couple weeks ago, or last week, whatever. But we are unboxing my guitar.
I knew it was your guitar.
And I'm using my trusty, rusty Milwaukee knife, and I'm going to see how this thing comes out of here. Yeah, it's looking pretty good. Like I say, 12-string acoustic. Let's see how it comes out. Oh yeah, wrapped up good. Alright, yeah. Can't wait to play this later, but
that is a 12-string.
Yeah, so 12-string acoustic, really love it. My other one had a few issues. I'm gonna have to go in and try to see if I read the instructions this time. I probably didn't do the instructions right, probably last time.
Yeah, tune that sucker.
Yeah, I'm gonna have to tune it. It has electronics on it, just so everyone can see. I have to put a battery in it. Should have got my battery back, but you put the battery in there and it has a tuner on there. So That's really sweet. You can just tune her right up. So, did my first unboxing live on the channel. So, appreciate you guys checking it out.
Awesome.
Pretty special to me. So I guess we're going to tool of the week.
Oh, yeah. Cue it up.
It's time for tool review of the week. Sponsored by Electrician's Only Tool Review and Nipex Tradesman.
All right, awesome. This week I came across a new tool that's just out. So if you guys have this tool and are using it, please hit me up. Let me know if you like it or not. I really like the 9 amp hour battery with the fast charger. So I'm kind of almost doing a review on the 9 amp hour battery and the fast charger. It charges up in less than an hour. And if this chipping hammer works like how they say it does, it looks like it's probably like the best thing you could get out there. A lot of these guys rent jackhammers. I don't even know. There's certain kinds of jobs that you run into where you have like this, like what kind of chipping hammer do you need? Are you just going to chisel up a little concrete, or are you breaking up slab? So this might not do like the breaking up slab kind of stuff. It might be more like a chipping hammer where you're just smoothing out a surface, trying to, chip out some stuff that is in your way. Like a lot of times, James knows this firsthand. The concrete guys like to pour concrete in our pipes, and then we have to like chip it out a little bit. But the whole thing is that what we have to look at is the way that the DeWalt is improving their package to where they're the most powerful, the fastest charging, and the best design out there. So I really appreciate pushing this week, and I really support the DeWalt chipping hammer. So if you guys have any reviews on it, let me know. And let me know if it sucks. Let me know if it's cool. Let me know. Like I say, it's brand new. I think it just came out this week or something, But we'll see. I'll try to rent one if I can, I'll try to tell the boss, like, hey, we got some concrete in our pipes again, And he'd be like, oh, damn it. All right, get you the whatever one you want,
Cool.
So it's pretty cool.
All right.
All right. Well, I think I'm gonna get you on this one.
Oh, question of the week. Let's see what you got.
Yeah.
Let's see. Man, person. Yeah. I think, what is this? It's like 410.12 or 18, something in there. I know you want me to say non-metallic, but that's not it. If I'm not mistaken, I think it's a C, unswitched type, if I'm not mistaken.
Well, I have some news for you this week. You are absolutely correct. What's so funny is, why did you say non-metallic? Because that's what ChatGTP said. Did you go look at ChatGTP? Did you go look up?
I never go over there. I don't care what ChatGPT says. They don't know more than I know on the code.
It was funny. I couldn't believe they said that, because a lot of people said sealed. And if you said sealed, I gotcha. But the thing is that is technically kind of correct with the sealed, because, you know what I mean? Like, if it's sealed, then it can be switched. But at the same time, like, how do you seal a lamp holder?
We actually had that question in our Journeyman exam and masters.
Really?
So, yeah, that's why I knew it. I knew, was it 410.12 or 18? I know it's somewhere right in there.
I think it's further out. I thought it was like 410 something else. Like, you could be right. I don't want to confirm or deny your statement, but I thought it was like further back at 410. I wanted to say it was like 410, 102, but I could be wrong.
I know it's in 410. I just don't remember.
Yeah,
the
it is.
section.
It is in 410. But all right, I got you once. I got, strike 10,000. All right.
Nobody's perfect.
hey, you know what? If I would not be having so much fun if it wasn't for the Willie Quiz.
Oh shit! Here we go. He says easy. That's a bunch of crap.
It's
Okay, here we go. Let's hit it up.
You are now entering the zone of the Willie Quiz. Enter at your own risk.
Dude, I can guarantee you Daniel J is going to swoop out of a tree and come in here just to beat you tonight, James. But the whole thing is, like, this is so much fun. It's so awesome. Like, there's people that have really good records against you, James. And one of them is Daniel J. I think he's got at least 2 wins.
I won last week. That's all I know.
Yeah.
Them others, I was sick. I wasn't feeling good,
Yeah. Well, I mean, I'm still waiting. Like, I know you're working on it, but you have to get the Daniel J. Knows all the answer podcast going. So, all right. So,
oh god.
This one's one of my favorite ones that I learned this week. What is the best way to extinguish a lithium-ion battery fire? Is it A, a listed ABC extinguisher, B, water, C, dirt, or AKA the earth, D, a mixture of baking soda vinegar, or E, pickle juice? Good luck, everyone.
Well, this is
So
interesting.
I know that you always like to rule out ones. So I'm pretty sure you could rule out pickle juice. I just thought that was funny. I thought that would give you a little laugh at the end.
I'm actually ruling out pickle juice, a mixture of baking soda and vinegar and water. So it's one of those dirt or listed. I'm gonna go with A.
A? All right. Well, we're gonna give a couple seconds for other people to answer the comments and all right. So A is a very good answer. That is very good. If you were to pick a second answer, what would be your second answer?
That wasn't correct. Is it C?
Now, C is a really good answer, but the actual correct answer is B, water. And I was blown away by this one. We were actually joking about this today when I was doing my paperwork, because it was everyone's like, oh, I just use water, kind of like the grease fire thing.
Yeah.
But actually, they say that's literally the only way to put them out correctly.
Really?
Because it doesn't, they even said something in there it created like a hydrogen reaction or something, and that was not true. So, and they said that they had lithium ion that were underwater for like days, and they still caught on fire after they pulled them out of the water.
Really?
Yeah, it was interesting. I read some stuff up on it, but we'll see.
That.
I mean, we got tons of those just chilling in a field in China, so that should be good.
I did not know that one.
All right. So, why are lithium-ion batteries flammable? The battery cells crossing polarity, a mixture of dissimilar chemicals. C, the release of energy that turns into flammable gas. D, uncontrolled release of energy that reacts with oxygen. E, factory smoke that is contained within a small space, and once it's released, fire occurs. Good luck, everyone. So I knew that this one was like real easy for you. You know, so like the thing was like it's pretty obvious what's like causes flames. Like it's once you release the factory smoke. Once the factory smoke is out, then it causes fire. See? It's really easy. I mean, E is the obvious choice.
No, it didn't. I know that lithium batteries, they contain a lot of energy in them.
Right.
And I'm looking at C or D is one of my two there.
Okay.
Release energy that turns heat into flammable gas or uncontrolled. So I think if the one that gets me is uncontrolled release of energy. I guess it would be uncontrolled if the battery come, split or something, and if it reacted with oxygen would cause a problem. So I'll go with D.
All right. D is a really good answer, but the thing is that C is actually the correct answer because it is a release of energy that turns heat into flammable gas. It's just not uncontrolled.
Right. That's what I was saying. The way that's why I was like, the only way the uncontrolled what was getting me, because my original answer was C, but I was thinking, well, maybe it has something to do with the battery went bad or something, and reacted with oxygen, and that's what was causing it. Yeah.
You should have went with your second answer.
Yeah.
Your second answer was correct.
Yeah. Well, I do that a lot, but
I did. Dude. I mean, dude, your second answer, you're 100% on your second answers.
Well, I did know they store a lot of energy. That's why I was like, it has to be something dealing with the release of energy.
Dude, I tried hard. I was sitting there thinking like, what bullshit answer am I going to come up with that's going to get Stallcup? Yeah. I'm just glad I got it.
I should have went with C because that was actually it really was my first answer, But
all right, cool.
Well, it
turns out to be your second answer.
and the reason I went with D is I was thinking, well, maybe something happened to the battery, and that's what was causing most of the fires.
So
but
that's the thing. Almost like kind of like we argue a lot with like these code guys. Kind of is. Okay, well, what if the battery splits open because a tomahawk throwing axe party comes in there? You know what I mean? Like, okay, well, you're going to get a release of energy that turns into flammable gas and it's going to cause a fire, But
well,
I thought you
were trying to trick me, and that's why I didn't go with C. I was there must be something that's there.
No, I would never try to trick you, bro. No, dude.
I did.
That's the last thing I want to do. That's dude. Everyone in here knows. Like, there's There's people in here that just jumped in the chat that no, I am not at all any way trying to trick you at all. That is horrible. Oh man. All right.
Well, at least
Let's go to number 3.
At least I knew there was a release of energy from the battery.
Yeah.
Okay.
Nah, you're right. You're correct. All right. So lithium-ion batteries are chosen to be used in power tools because they are blank. A, excellent at heat dissipation. B, the lightest known metal. C, not a nickel-cad based battery. D, best at powering bass fishing. Dude, I'm thinking guitars, man. I was thinking bass, powering bass fishing motors. I put that in because I knew that D is absolutely gonna be the correct one. But good luck, everyone.
Well, I would have to say I just know D's not it. I know B's not it.
Dude, I'm telling you, I'm gonna tell the bass fishermen out there that you just don't got their back on that one. But
Yeah.
all right.
I know they're really good at heat dissipation.
Yeah.
And plus, it's not nickel cad.
Well,
I have to go with A.
hey. Well, that's a really good answer. I mean, that's probably one of the best answers you've had tonight. But what would be your second answer if I told you that? What? C?
Yeah.
So C is actually a good answer too, but the answer is B, is the lightest known metal. That's why they put them in cordless tools, because it makes the cordless tools light, and that ties in my whole tool review thing with how I gotcha, brother. And the whole thing is, I love getting you, James. It's so much fun, and everyone learns. And James is a really good sport. Like, it's so much fun doing that. He has like really good guesses. I make him so easy that he has to like guess, and it's so much fun. I'm really sad that Daniel didn't show up and just go boom, because I probably told Daniel at one time.
Like I say, sometimes I go 3 for 3, and they're like, he knows the answers. Then I go 0 for 3. Like, I don't know the answers.
Yeah.
I'm just guessing at this stuff.
Yeah. Well, it's a lot of fun. Like, everyone that follows us, like, they know the truth that we just have fun, and like, we don't care. Like, we get attacked by all these so-called code guys that say all this crap, and then we go in there and we prove them wrong, and then they get all butthurt. They go out on social media, try to clown us, say we're wrong and whatever, and say I'm a cancer to the industry and all this stuff. And like, dude, I don't care. You know what I mean? Like, that's cool. That's fine with me. You want to call me a cancer to the industry because I'm improving everyone's knowledge, then whatever. That's on you. That's not on me.
Doesn't bother me one bit.
Dude, it's so funny when we're sitting there like asking Weed Man in the debate, where is the outlet? And he's like, the outlet's inside the AC equipment. It's like, how is the AC equipment the outlet that feeds itself? And he's just like, total quiet, just dead quiet, dude. Just, and then, it just didn't know what to say. It was so funny, man. And then I was just like, dude, tell me how the AC unit, the utilization equipment, can be the outlet that feeds itself. Just tell me how it can be that. And he just didn't know what to say, and it was so funny. And then he's like, piss off, assholes, or whatever. And I was like, all right, whatever. I was like, later, dude.
I'm still waiting for somebody to tell me where you draw the energy from an outlet.
Yeah.
Just like a receptacle outlet. Where do you draw the energy from that outlet? I thought it
Yeah.
was a device. You know, I'm still waiting for somebody to explain that to me, but
Yeah.
we'll see.
And the thing that's so awesome is the electrical wall of shame is close to 125,000 members. That's so awesome that we have that many people out there that are jumping in. And so we are going to roll the electrical wall of shame for this week.
All right.
Shame. 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 Shame.
So this one this week is really funny. I should have put the name of the gentleman who posted this, but this is a PLC cabinet or some kind of a control cabinet, some kind of a termination cabinet, and you can see how it looks really nice up by the top where they use the zip ties, and then it just gets out of control from there. And
Damn.
it's really funny because we just did this where a couple weeks ago where we talked if dressing the panel with zip ties causes bundling, and I don't know, I would almost say there's more hazards with this than the bundling issues that you would have by dressing that panel.
Dang right there is. That is, wow. I wouldn't want to work inside that. That is nasty looking.
Like to me, my OCD just starts ticking off, and I would just have to like clean it up. I would have to start at the top, start taking stuff apart and redoing it and making it look better.
Looks like they got a lot of extra cable that's just laying down in the bottom of the panel.
Yeah, that's like I'm an anti-looper. Like I don't like loops. Like a lot of guys that just do a loop at every single one just in case or whatever. I don't do that. I don't run that.
That looks bad.
I don't run
That is wow. That looks.
But it's
really
crazy.
bad.
Like if you go look at that in the electrical wall of shame group, you will see that it looks almost okay where it comes in on all the ways it comes in, and then after it does that, it just goes to hell. You know.
Yeah.
So I mean, it's funny. Like I really love all the people that's in the electrical wall of shame group. It's really awesome that you guys post all your service call stuff, all your little nightmare stuff. It's pretty cool. Like we enjoy it. Like I've actually talked to people that like close acquaintances of mine, and they're like, "Oh, I had to leave that group. Like everyone wants to rate their panel or do this or that, you know, whatever." So you know, it's just really funny because I don't really care about that. Like personally, like we're trying to just have a fun group, and if you're like, hey, first year apprentice and it's a beautiful panel and you want to post it on Wall of Shame, you're gonna get torched. You know, like it doesn't matter. It could be the most perfect panel you ever freaking installed in your life, and you're gonna get torched. But it's a good torch. You know what I mean? Like,
oh yeah,
like I enjoy it. Like when I put my stuff in there, everyone's like, "Oh yeah, you're such a brave guy." I was like, "Yeah." They're like, "Put your work in there." I was like, "All right, I put my work in there." You know. And then they're like, "Oh, how dare you put your work in there?" I was like, "Whatever." I was like, "I don't care." I was like, "It looks good. It looks fine." They're like, "Oh, the box is sized wrong. This is, you know, you didn't use deox and we had Crystal Hunter on here, and I thought her take on it was really good, where she's like, well, you know, they put deox in the splices.
that's right. They do.
And that's because they don't know, is it going to be aluminum, is it going to be copper?
That's right.
Now, are you going to be the installer out there and be installing it and know?
Well, it brings me back
or are
to
you
one
going
of
to be
the
the manufacturer that doesn't know?
brings it back to the point. You know, that's a listed and labeled product.
Yeah.
There's a reason they put it in there, you know,
Right.
and it goes back to prove exactly the things we've been saying. And, you know, it's just like, you know, we've had some of them out there say, oh, the code overrides the listing and labeling. No, it doesn't. It does not
Yeah.
override it. The listing and labeling overrides what the code says because it's been tested for safety and everything else. That's why you got UL standards to design by. And that's why I have a problem with some. But, you know, what I've noticed, they only do that when they need to pick and choose because it didn't meet in their narrative. That's usually when they do that.
Well, what's gonna be the problem? And this is the whole reason I wanted to jump in there from the beginning is that I see a problem with the NEC credibility. I see the NEC credibility going downhill. Like basically the HJ adopts the NEC. The representative for the AHJ enforces the NEC. And when they start seeing all this being a whole pile of bull crap, like they're not gonna be enforcing it. I mean, it like they said. Oh, they just texted me tonight, like, oh, 2029 is pretty much a done deal for the radical changes you guys talked about on your episodes. Okay, cool. You know what I mean? Like we never said that code changes wouldn't happen. We just said that they wouldn't happen in 2026. And then they're like, oh, that's not a myth. I was like, yeah, it's literally a myth that it's going to happen in 2026.
Yeah.
You know, I mean, I don't care. You could, you know, wrap it up however you want. But if it's going to happen in 2029, I think you're presumptive, you know. But the whole thing is, like, I don't care. If it's going to happen, cool. It's going to happen. Like, I don't, if the code is going to change the freaking code. I don't care. You know, but to change it the way they want to do it is freaking radical as heck.
I think one of the most important things that happened with all of that is the Standards Council. And the reason is because the Standards Council is going to hear the final arguments. You know, as a good example, you know, when we were discussing on the outlet and stuff, they were telling me TIA passed so-and-so, you know, that code making panel 2 put together. And I told them that time, I said, well, you can go ahead and hold your hat to that. I said, but when it goes to Standards Council, I said, it doesn't have the technical merit. And you're going to have the other side present. And I said, that TIA is going to get kicked out. And they're going to put that other TIA in that they actually did all the technical data to prove our points and stuff. And they told me, you don't know what you're talking about. You don't know the code making process. But even though I've been doing it for 30 years. And sure enough, went to Standards Council. What happened? It got kicked out. And they put the new one in. And, you know, and I told them, I said, you know, when all that was happening in 2023, I said, hell, I said, even if they're able to do something, I said, it won't even happen to 2029. And they say, you don't know what you're talking about, blah, blah, blah. And sure enough, here come 2023. Now it's 2026. They're not going to do it. You know, just like I told them.
It's going to 2029. We know it. The whole thing was, that's so funny, is that we basically told them, like, hey, what they're trying to say that GFCI, Class A GFCI, basically, it shined a spotlight on a problem, you know?
Sure did.
And that's cool. But where is the real problem? Because that's what our problem is. That's what our problem always has been, is that, okay, so this kid got killed in 2007. That's tragic. That sucks. But now all of a sudden you're going to go in 2020 and say, okay, now we have to have Class A on all this stuff. Like, I mean, if there was like 3 British kids in Egypt playing next to a hardwired AC unit, soccer, and all 3 Egypt kids got killed, yeah, we have a problem in America. Like, but the thing is, when you have an American kid who's jumping a 6-foot fence on an AC unit, like, you come to a point where you're like, I mean, yeah, it's tragic the kid died, but it's like, you come to a point where you're like, dude, if you're a parent and your kid's jumping a 6-foot fence on an AC unit, you're like, what's wrong with you, kid? Like, you can't do that. Like, that's trespassing on somebody's property, damaging somebody's equipment, like, basically getting yourself killed. Like, I mean, yeah, that's horrible. But at the same time, it comes to a point where it's like, we can't just say, do not stick fingers in lawnmower. You know, like, yeah, no shit. Do not use lawnmower as a hedge trimmer. You know, I mean, come on. I mean, that's my point on it. We're coming to this society where we can't just do this forever. We can't just keep, dumbing down society because of this warning thing, you know?
Mm-hmm.
And that's my frustration with it, is that why are we doing this? Why are we saying, oh, now every person, like, basically it's saying, hey, this one kid trespassing on somebody's property in Southside Chicago just ruined it for all parents. Now all parents have to have Class A protection on their AC unit. Well, now, what if their parents are caretaking for an elderly person, and then next thing you know, that elderly person passes away because that AC unit failed or it got shut down? The elderly person is not able to go reset the breaker, go, take care of it.
Mm-hmm.
That's a problem. To me, that's a problem. And they fail to address it. They want to solve it with arrogance and say that we don't care about kids. We don't care. To me, it's arrogance. It's just arrogance. Like, you just need to do what we say, and that's it. And it's frustrating to me. I don't understand it. I don't get why they think, like, I mean, dude, UL can just give them the finger and it's done.
The manufacturers are going to end up doing that. Just because Code Making Panel 2 wants GFCI protection on the AC unit, that doesn't mean the manufacturers have to do it. If I was a manufacturer, I'd just put in my specs, no GFCI protection, done deal. And you can do that.
They were at the Code Making Panel. I got this on first-hand information from Code Making Panel 2. And they actually asked the manufacturer, one of the manufacturers, and they're like, hey, we're thinking you should pull a neutral. And he's like, all right. Yeah, pull a neutral. The end. Like, why do you need all this Class A protection? Like, pull a neutral. Like, do you have to have Class A protection on a, like, different, like, the thing is, we're in 2023 cycle. Like, if you're in 2023 cycle and you have, like, a range, then the range has to have a neutral and has to be Class A protected, regardless if it's in that kitchen, So, it's getting to the point where it's pretty much everything in there, but, like, let's just say, like, there's a coffee maker, and you just hardwire that coffee maker. Well, GFCI protection is not required because there's no outlet.
That's right.
So, I mean, it's just that whole thing, like they want to pick and choose what they want to enforce, and you can't just hardwire your coffee maker into your wall now because it has to have Class A protection, like, from their standpoint. Like, I'm totally down with it. Like, we've done it before. Like, we've hardwired 208 volt European coffee makers in kitchens before, and they're like, hey, does this require GFCI protection? I'm like, nope, we hardwired it.
It's going to be interesting because I'm sort of waiting to see what Code Making Panel 1 says, because I gave them an example and I want to know where the outlet's located.
Yeah,
and
I agree.
If they say it's at the equipment, then and I'm going to reply back. So the equipment's feeding itself? Is that what you're telling me? That you're drawing your energy from an outlet it's drawing its energy from itself. I mean, you know, that's where it's going to get interesting, because if that's the case, then you just might as well delete the definition of receptacle outlet. And that's why I kept co-making panel 2 out of the correlation I did with all the definitions and kept them separate on their definitions, because I want co-making panel 1 answering these questions. And if they say there's no outlet, it really, at that point, it doesn't matter what co-making panel 2 wants or does, because it's a done deal.
I posted one for co-making panel 17, and it was funny. I think I caught them off guard a little bit, because they said, like, if you have like an AC unit that's like really close to a pool, then that's gonna be defined as other outlets, and it has to be more than 10 foot away from the pool. Well, there's a lot of places, like on these rooftops and stuff, like there's no way you could place these condensing units like 10 foot away from a pool. Like, you just can't do what they say you have to do, you know?
Right.
And it kind of caught him off guard, and I was like, I just want you to say, and I think it was 680 24D possibly, but, or 25D, I don't know, I remember, it was 20-something D, that other outlets are required to be 10 foot away from pool edge, you know?
Right.
And so, okay, so in one case, the disconnect's the outlet, so you can put the disconnect 10 foot away from the pool, so you can call the disconnect the outlet, you're good to go.
Right.
You know, but then they're like, no, the unit is the outlet. Okay. Well, now you have to have the unit. So what, you could put the disconnect right next to the pool, you could feed the branch circuit all the way to the disconnect, then feed the disconnect all the way back to the condensing unit. And even though that switch is within 4 foot of a pool edge, it's okay because the condensing unit's more than 10 foot, because you're calling that the outlet.
Yeah.
Like, it's ridiculous. Like, it's just like they have to have some consistency in it.
Well, the great thing is we're about to find out, and I think once we know how the co-making panels vote and everything, that might be one of our myth of the week or something like that. Is there an outlet at anywhere on the AC unit? And run it from there. So,
dude, I'm telling you, the whole thing is a good myth is, has anyone ever been killed by an outlet? You know what I mean? Because what is the actual outlet, and then has anyone ever been killed? Because the substantiation for 210.8F is basically that there was a child killed by an outlet. And then you're like, okay, where was it? And they're like, we don't have to tell you. You know what I mean? You're like, okay. That's weird.
Well, we'll see. It's coming.
Yeah.
We'll know here pretty soon.
Thanks a lot, everyone, for checking out my first ever unboxing. That was awesome. Like, I can't wait to play this new sweet guitar.
Yeah, you gotta get busy on it now.
Yeah. I'm gonna make James a new intro song for the topic of the week, because his topic of the week is, it's not jamming music, brother. Yeah. I'm going to have to make a new one, so I'm going to get to work in the studio and make him something good. But I appreciate you, James. Thanks for moving the show tonight. It means a lot. I mean, dude, I can't believe we cracked 2 hours tonight, you know?
Yeah, I'm getting hungry. I'm ready to go eat. I hadn't eaten today. I've been busy with all kinds of crap.
Well, I'm so glad that Pops ain't there hounding you and giving you the...
He probably will be in a minute. He'll probably be like, let's go eat.
Mile high salute. Dude, it's so funny. Like, everyone at the job site's like, oh, man, James is going to take so much crap because of the way the Cowboys played. And I was like, I think he's used to it.
I'm still hoping they trade Dak. I'd love to see him or just cut his ass. I don't think he's going to do anything.
Well, I remember, like, I think it was like maybe last year or something when Rush came out, and he was doing good and everything, and then they just put Dak back in.
Well, it was
Back
funny
to
because
St.
we
Louis.
went over to my niece, and they were cooking dinner for Dad and stuff. He wanted me to go with him. I said, all right. And we were talking about it, and she goes, you always like Dak, and Dad goes, no. Said he was the one that said they should put Romo back in, and said that was all that he didn't believe he was that good. And he said if there's anybody here that maintained it, he didn't like him as the quarterback, it was him. And I don't know. When you watch him, it's like if things are going great, he's good. But if something's going wrong, he can't fight through. He's not like a Tom Brady, Jordan Love. I like Jordan Love with the Packers. Those guys move around stuff. Dak, I don't know what it is, but his eyes get wide. Like he's lost. And you see that whenever it's a big game. He never plays good in a big game. It's always against the teams that are lesser talented than what the roster the Cowboys actually have.
Who you got for the Super Bowl?
I don't know. I think it's going to be Baltimore wins it all. That's who I hope wins. I think they got a good team. I think Lamar Jackson.
Yeah.
I think he's.
I'm going Lions. I'm going
Why
Lions
not?
all the way.
The Lions
I'm taking
looking
Lions
pretty
to the
good.
house. Yeah.
I really
mean,
thought
dude,
Buffalo would be the team coming out, but they got beat. I really.
Dude, that was the craziest game. Like I went and watched that game down at my local pub, and I tell you what, like it was like a haymaker to the face, and then a haymaker to the face, and then a haymaker to the face, and a haymaker to the face. Like that whole entire game, just back and forth, and then Buffalo just out of the blue, without even throwing no punches thrown, just boom. You know what I mean? Like when they missed that field goal, it was game over. You know what I mean? It was like what? Like, it's like they were still standing, they were still fighting, they were still there, but all of a sudden they just boom.
Well, honestly, I like Dan Campbell as coach.
Yeah.
I like he just tells it like it is. I hope Detroit wins it, but I think it's going to be Baltimore. Well, I really like Dan Campbell. I think Dan Campbell's a hell of a coach. And
I think Detroit would deserve one. I mean, it's well deserved. I mean, like they went in as a strong contender, and they're in the black and blue division,
Yeah.
And they always get smoked in the black and blue division, but they're looking good. I mean, they're
I'm looking
solid
forward
team.
to it. What?
Yeah.
Okay, I gotta wrap it up. He's wanting to go eat.
Hey, make sure and give Pops my old. Hey, I love you, brother.
I'll
Love
give
you,
it to
love
him.
you, Pops.
All right, let's wrap it up. Everybody
All right,
have
brother.
a good week.
Have a good night, sir.
All right, take care, everybody.
Later.